Hello guys, I'm here with another Let's Play in Minecraft. Obviously today we're going to do the Lagrangian. Now, let's do this. You see L, this is the Lagrangian. Let's define it. Let's say it's a variable of y, the time derivative, dy over dt, and x. And this is the Lagrangian, but why? Why is this the Lagrangian? Why with respect to t and not x? Why is this not x prime? Good question. And why is this not x? I said prime. I should have said dot. And why is this not x? Well, let me show you the general Euler-Lagrange equation. It's going to be d over d some variable. Let's say, I don't know, a? I really don't know. Okay, and this, and then there's some q, some variable q, time derivative of it, or some other type of derivative. Doesn't matter what type of derivative, just it could be with respect to x, it could be with respect to t. Then you have this, q equals 0. It has a nice pattern, doesn't it? I'm not teaching you stuff properly, by the way, I'm just making you a parrot, but it will help, I hope. So this, notice, it's the only difference between this and that, only difference is the dot, which is a derivative. D over dt or d over dx or whatever. It could be anything. And by the way, when you get problems in life as well, I know you've got other problems too, but there was a quicker way to do that. Sorry. Anyways, so I forgot what I was saying. Oh yeah. So let's say the Euler-Lagrange is what I said. That means, so just look at that. That means you have to do this. Let's say we're taking the time derivative. The context here is physics. With respect to y dot minus. Let's say equals. Let's write it in this form. It's the same form. Instead of a minus here, I put it to the other side. Anyways, you also need to do this, but this is probably 0 in the context. Because we don't generally have only one Euler-Lagrange equation. We generally have more. In fact, let me do this. Q1, Q2, Q3. Let's say Qn. We will have n Euler